go through and check that warm up. If you cannot do that warm up, you're gonna get plenty of practice these next couple days on that, but you got to start there. Okay, on number one there. First thing I'm always looking for is, do you got yourself that rationalizing correct? Because if we can't do that, you are dead in the water for the next few days. So you're gonna get plenty of practice though. Rationalize. Square root of 18 is where you start that thing, and then across. Multiply across 7 times 18. Sorry, 7 times square root of 18. I don't got a lot of room there, so I'm gonna move it across here. 7 square root of 18. Denominator. I don't care what 18 times 18 is. I say you don't need your calculators. Also don't need your phones. So with 18 times 18, it becomes a perfect square. And square root of 18 times 18 just takes you right back to 18. Okay, that's where we're at right now. If you got me that as the first answer, cool, you're off to the right start. Now, after that, square root of 18 goes a little bit further though. Take 18 off to the side, 7 square root of 18 off to the side. You guys have been doing that since day 2 here. 2 and 9, 9 and 2, whatever you want to do there, but then simplify that radical. Square root of 9 is what? 3. And what is 7 times 3? 21, right? Mm-hmm. So I'm going to bring that back in as 21 square root of 2 over 18. And the unfortunate part about rationalizing here is once you think you finally are done, not the case. What else can we do at 21 over 18? Simplify. Reduce it by 3, right? We can reduce it by 3. Reduce by 3, what is that? 7 and 6. So 7 root 2 finally over 6, I believe. Okay? That one is a little bit more involved, but that itty bitty skill is what we are using. The next one here, 8 over the square root of 2 root 3. Okay, again, peeking over some shoulders a second ago. Multiply by root 3, multiply by 2 root 3. I don't care, I'm lazy, I'm going to take it by root 3. You can take 2 root 3, but at least root 3 is the bare minimum. Okay, numerators, like what we did there. And as I said, you're going to get a lot of practice with this the next few days, so it will eventually click for you. Make sure you multiply. 2 square root of 9. Perfect square. There's that 9. Square root of 9 is 3. 2 times 3 right here makes it 6. Can you take that 8 square root of 3 off to the side and simplify it? No. So we bring it back over. And again, one more time, once you think you're done, check yourself. Can you do anything with 8 6? Right. 2, which gives you what? 4 and 3, right? Okay. At no point on here, today, tomorrow, first few days here, should I ever get 8 decimals. I'm looking for all fractions, all radicals. Okay? So let's go here. Let's use that skill, and let's start off today. What we're going to look at today is some special triangles, and we're going to go back to our very beginnings here. Take your work, go find me x. What's the only thing we know how to do right now? To find x. What is the one tool that we have that allows us to find x there? The only thing that we have for right triangles is Pythagorean theorem. So go take a quick minute on that example 3 and 4, and go find me x on both of those. Okay? Go answer me out those questions on questions 3 and 4. What do we got here? You found x on that first one. Luke, what'd you get for that first x there? Root 2. Okay. And then on the next one, Patrick, did you get x for the second one there? I got 3 root 2. Sounds good. Let's classify these triangles and find the missing angles. Jillian, what did you get for these angles up there? 45. Right. 45 here and 45 there. And surprise, surprise, what do you get on the other one? 45 and 45. Which leads me to classifying that triangle. So then, Ginger, what type of triangle is that? Yeah, it's not just a right triangle. It's not just an isosceles triangle. They are together, right? Isosceles. I just had a brain fart. Spell that for me, guys. Oh, C. There's another O there, right?
Yeah.
Okay. Wow. I just completely lost that.
Yeah.
Is that right?
Yeah.
Okay. Just not sounds right. Okay. So we have ourselves two isosceles right triangles. Again, reason why they're isosceles is these two legs are congruent, which implies those angles are congruent. Now, if I threw out another triangle to you, and it's not to scale, and I said that these two legs are, say, 10 and 10. Look at your pattern. What's my hypotenuse?
10 or 2.
And one more time, what is it?
10 root 2.
And if I went right here and said this is 17 and 17, look at your pattern. So there definitely is a pattern happening here with this 45, 45, 90. So this is our first special right triangle where a pattern is definitely happening here. So let's create that pattern. Let's generalize it out for today. So in this 45, 45, 90, very nice, Patrick. Okay, with this 45, 45, 90, let's generalize what's happening here. In our triangle, okay, this is what's going to drive the rest of the school year, Algebra 2, Physics, Pre-Calc, wherever you're going. Okay, what is true about the legs? The legs are congruent. Okay, and we're going to bring in the SAT. Now, it is your job to remind me on the quizzes and the tests from this point on to hand out the SAT formula sheets. SAT does not give you very many formulas, but of the formulas they give you, that is one of them they have out here. This is what we call a reference triangle. And on the SAT formula sheet, they say the two legs here, they use the variables S and S. I hate it. I use X and X, but they use S and S to say, hey, these two legs and legs, side and side, are congruent to one another. Okay, now, what is the relationship to find the hypotenuse? The length of the blank is blank times the leg to the length of either leg. The length of the hypotenuse is what? Is the square root of 2 times the length of either leg. So S square root of 2. So with that now, that is our reference triangle that you will get burned into your head. This dude will not leave you. S root 2, or 45, 45, 90. We are going to use that. Get yourself a tattoo. If you don't make it permanent, get a henna tattoo. Okay? So, S root 2, from here to physics to pre-calc, it's not going to leave us. Okay? We're going to be doing a lot of that. When I say know your two reference triangles, there's our first one. Tomorrow, we're going to look at the other special right triangle, which is the 30, 60, 90. There's a certain pattern that happens out there. S root 2. Let's apply it. Let's use it. Let's go down below. Number 5. All right, go. On number 5, go find me X and Y, and let's go do number 6. Okay? Another quick minute. Go find me 5 and 6 with you and your buddy. Not as quick to see here. It's the hypotenuse given to us, right? Mm-hmm. We got the hypotenuse given to us. The reference triangle says it's S root 2. But what does number 7 have the hypotenuse? Just 2. Does it have a root 2 on there?
Nope.
So we cannot just say it's 2 like we did in the last one. I'm still going to do the exact same thing. I'm going to say 2 equals S root 2. Now I'm going to use my equation skills to solve. So let's do that. Solve for S. Solve for the leg. How are we going to solve for the leg? We're going to divide by root 2. Use your equation skills from 6th grade, 7th grade, 8th grade, Algebra 1. Divide by root 2. What happens to the root 2's here? Right. Now, here is where we are at from our warm-up, from what I've been trying to prepare you guys for heading into here. We have 2 divided by the square root of 2. We need to now rationalize that. Okay? There's no root 2's to cancel on the left side, is there? So we have to rationalize that. So go back to the warm-up. Let's rationalize it. Rationalize by multiplying by root 2 over root 2. Okay? That's that skill now that is now needed. We're going to use it. Okay, let's do that. Numerator, 2 times root 2. 2 root 2. Denominator, root 2 times root 2 is? Right. It's a square root of 4. Square root of 4 is perfect, which is just 2. That answer is good, but it's not great because what can we do? Simplify. 2 divided by 2 is cancel, and the final answer is just correct. So that leg, both legs, x and y, both turn out to be the square root of 2. That pattern is still there. It's not as obvious from what we started off with. 3, 3, 3 root 2. 2, 2, 2 root 2. That kind of just rolls off the tongue kind of nicely. Root 2, 2. It's not as obvious, I think. It's still there because now if I go back to that, what's the square root of 2 times the square root of 2? 4. And what's the square root of 4? The pattern's there. It's just not obvious because that hypotenuse did not start off with a square root of 2 there. Okay? So, boom. Let's go to the next one now. Take number 8. You're your buddy. If you haven't done 8 yet, go find me 8 now. Okay? Realizing that 5 root 2 represents the leg, right? So what's my other variable up there? 5 root 2 is n, right? Okay. As I was listening to Yante there say, realizing, hey, that again is the leg. Going from my reference triangle, the leg times root 2 gives me the hypotenuse. So m is the leg times the root 2. All right, that's it. What is 5 root 2 times root 2? Root 2 times root 2 is square root of 4. Square root of 4 is 2, and 5 times 2 is 10. So for a few of you that only had 5 there, did you catch your mistake?
I did.
Thank you. All right, let's do a few more. Flip it. Okay, on this next one here. All right, let's go with number 9. All right, sketch out that picture. No picture there. Let's make the picture. They say it's an isosceles right triangle. What is isosceles right code for? Make the picture that makes an isosceles right. When they say isosceles right, that is code for a specific triangle. What specific triangle? What we've been talking about today. Isosceles right only means one specific triangle. Okay? 45, 45, 90. Okay? And based off of that, now label it out. What do you have in this case? Where the length of the leg, which leg is it? Well, it doesn't matter, does it? Okay? So that's what they just told us in that sentence. Now what can we immediately find? The area or the perimeter? We've got the area. We have the area first. Let's go back to, bless you, first semester we did some work with area of triangles. All right, area of a triangle, everybody, bless you. Area of the triangle is what? 1/2 base times height. There you go. Base and height, remember, have to be perpendicular. We got those two legs that are perpendicular to one another. Okay, so let's go do that. 1/2. So 1/2, 2 root 2 times 2 root 2. Don't need a calculator. 2 root 2 times 2 root 2. That's what we're going to start first. Take it to the side. What is 2 root 2 times 2 root 2, everybody? 2 times 2 is 4. Square root 2 times square root 2 is 2. I think
8.
I might have added myself. Sorry, square root 2 times square root 2 is 4, and that gives me back to 2. And 4 times 2 is 8. So what is 1/2 times 8? Yep, this is 4 square units. That's all we did. We just multiplied radicals. I took half that, 8. How do we find perimeter? Add up all sides, right? Do I have all the sides?
No.
Go find me the third side. So 45, 45, 90. Let's use our reference triangle. Our reference triangle says what? Leg times root 2. What's my leg? Leg is what? 2 root 2. What's 2 root 2 times root 2? 4. Okay. So the hypotenuse is what? 4. 2 root 2 times the square root of 2, which is, as you said, 4. Walk it around. Add it up. Add it up, add it up. Like terms, this takes us back to like day 4 here. 2 root 2 plus 2 root 2. Those are my like terms. What's 2 root 2 plus 2 root 2? 4 root 2. Plus 4. Remember, you can't do anything with that. We stop. We're done. And I just realized I forgot my squared right there. Okay. All right, number 10. Number 10. What do we got on number 10?
The right triangle?
What's that? Not
Yes.
an isosceles right triangle. Thank you there, Patrick. So what are we going to use on number 10? Thank you. On number 10, we are using Pythagorean theorem. Just because we're focused on special rights today and tomorrow in trigonometry, don't forget about Pythagorean theorem. What up there tells you it's a 45, 45, 90? Nothing. Patrick said it's not a 45, 45, 90. It's not isosceles right. So don't forget about our good old Pythagorean theorem. We're not going to solve it out. But what I want to talk to you about this one is don't forget about everything that we've been doing so far this school year, meaning our Pythagorean theorem. Something's in there that's going to tell you it's a 45, 45, 90. Nothing in there tells me it's a 45. So don't forget about relying on good old Pythagorean theorem. Okay? All right. Go graph me that line, everybody, on number 11. You haven't done so yet? Go graph me that not line. So, yeah. Y-intercept starts it off, right? All right. I think we'll probably remember that. Might have blocked out that part of.
But like.
-2 starts it. And the slope is, I heard, 1. But it's got to have a run. So we put it over what? 1. So remember, slope is a set of directions. The y-intercept is a starting location. It's a point. Slope is a set of directions of how you move. And rise and run tells me what to what. Up 1. And I don't know what over means. Thank you. Right, I know. I'm just always very specific. So up 1, right 1. So up 1, right 1. And I like to give myself as many points as I can. Up 1, right 1, up 1, right 1, up 1, right 1. And then I always tell my kids to reverse up 1, right 1. What does up 1, right 1 reverse mean?
Down 1, left 1.
Thank you. Down 1, left 1. My kids are doing in Algebra 1 using this right now for another topic. Take that line with your ID. That's why we have IDs. Make the line. It's not for security purposes. Make your lines in that class.
I mean,
Maybe security purposes.
who actually?
Okay. Now, what does this actually say? Find me the measure of the acute angle that each line makes with the horizontal. Well, here's our line, obviously. Let's go find a horizontal line up there. We got a bunch of horizontal lines. We got a horizontal line with the x-axis with all these horizontal lines on this grid. Let's just go ahead and pick a horizontal up here. Let's make a horizontal right along here, okay? Here's a horizontal line. What they're talking about is finding the angle that each line makes, that the line makes with the horizontal line. So here's my acute angle. That's the angle that they're referring to. We want to know what the measure of that angle is. And this begins our process of finding the measure of missing angles, which we'll do over the next couple weeks. We'll roll this into trig. Let's make a triangle, guys.
Oh, I see what you're doing.
Let's make a triangle. Let's make any old triangle. Let's make a right triangle, though. I'm going to drop from right here. You can do it wherever you want to. I'm going to drop this right here to make a right triangle. I dropped it from where? 1, 2, 3, 4, 5. Now, when I dropped it right there from 5, what type of right triangle did I just create? Not just any old right triangle. But yeah, go count now my rise and run on that. Go count my horizontal and vertical legs. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. I didn't create, again, just any old right triangle. I did create a very specific one. I created a isosceles right. Because when I counted that legs, as you just said, I got 5 and 5. So what's the measure of that angle?
45.
It's got to be a 45, 45. Okay, the angle has to be 45 degrees. Now, what is telling me that it's going to be a 45? The slope did that. The slope's doing that. I could have gone and not dropped it at the 5. I could have done and dropped it right here at the 3. If you went to the 3 and did it, hey, this is 3 and that's 3. I could have gone back here and dropped it from the 6. And I still get the exact same. These are all similar triangles. What did we just talk about in the last topic? Similar triangles. These are all similar triangles, except the only difference is one's smaller than the other or larger than the other one, right? But they're all similar triangles by AA similarity. They're all sharing that same angle and a right angle as well. So these are all similar triangles by AA similarity. And what's commonality there? That slope is starting off as the same. Enlarged by a factor of 4, enlarged by a factor of 6, whatever you want to call it. Okay. Slope is in. Slope does it for us. Okay. Same thing's going to happen on this one. Let's go to the next one real quick. Got to put in y equals though. Got to put it into what? Slope intercept form. How am I going to put it in slope intercept form? Negative x. Thank you. Negative x. What's my y-intercept then? Positive 3. And what's my slope then? Negative 1, 1, which means what? Down 1 and right 1. Play that slope game. Again, the y-intercept is a location of where to start off with. The slope is a set of directions of how to go from one point to the next. So play that slope game of what? Down 1, right 1. Do as many points as you can, and then reverse it. Down 1, right 1, plus it means up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. Take your ID, make that line, and off this one, pick a horizontal line. Anywhere off that horizontal line, off that decreasing line. I don't care where you pick that horizontal at. Julia. Okay, but it's not going to matter. Okay, Jillian said, "Hey, idiot, you put it at a negative 3 instead of positive 3." She's an idiot. Okay, but it's not going to matter though. Why is it not going to matter? I got the same slope, and it really doesn't matter if my slope is positive or negative either. It's going to be the same thing, right? So even though I did a wrong y-intercept, thank you, Jillian, it's still not going to matter because off of any of these, okay, I still get the same right triangle, correct? Um, Off of here, hey, there's that 3, 3, isosceles right triangle. Hey, here's that 6, 6, and if I would have shifted that up, translated that up to 3, I'm still going to get the same right triangle. Okay, thanks, Jillian, but it's still going to give me what type of angle? Yep, 45 degrees. That's what I wanted to, again, keep bringing out to you. All right, let's finish strong here today. Let's bring in the challenge mode. So we've done these. We've done these with Pythagorean theorem, where we have to find an intermediate piece. We got to find a shared side. Where's my shared side? Yep, that middle one. Let's call it what? Yeah, Z, Y, A, Bob, Phil. Probably not Bob and Phil. But let's call it Y. Let's call it Z. I don't really care. But we got to find that. That links it together. And then we're good to go. Okay, so I like to usually separate these out. Where I got a 10 here and a Y there. And just like we start off today with. Okay, you got a 10. What's that 10 represent? What's that represent? S or S root 2? Right, my hypotenuse. So I'm going to set that equal to S root 2, solve for my Y. Now, unfortunately, it's not a quick one. It's not 5. You got to divide it. You got to rationalize it. We're going to divide that by root 2. And as we do that, what happens to those root 2's on the right? And eventually, I know some of you are going to get very quick enough that you're going to be able to see it rationalize in your head, unless you're already there. If you're not, that's no big deal. You'll get there, usually. Rationalize the denominator by multiplying by root 2 over root 2. And that numerator, 10 root 2. In that denominator, perfect square of 4. Square root of 4 is 2. Can you do anything with that?
No.
10 divided by 2 is 5. Now that's not my final answer. That is that Y Deontay said we got to get first. So imagine now we have that as a 5 right there. 5 root 2. That's a 5 root 2. That's not my final answer though. We got one more triangle to pull apart. Okay. That is what? 5 root 2 here. And what does that 5 root 2 represent? The hypotenuse again. What is, that's nice. Why is that one nice this time? It's got the root 2 on it, doesn't it? So 5 root 2 is the hypotenuse, which equals S root 2. And the reason why that one's nice, if you're seeing those patterns happen, and I've been doing a ton of these over the years, I know that one's nice is because it equals S root 2. What I'm asking you to realize is, hey, what does it represent on a reference triangle? If you can't match up that, you're done for. If you're not seeing the quick pattern, okay, that's no big deal. What's going to happen algebraically here is these root 2's are going to do what? They're going to cancel here and here. And I know a lot of you are able to tell me immediately 5. X is 5. Absolutely. I'm not going to worry about the perimeter with you. Okay? I'm not going to worry about the perimeter. All right, that's where I'm going to shut up finally and pause it.